All right, so this would be section 6.4 through 6.6, part 2. So now we're going to go into our reciprocal functions and look at those graphs. So these are going to be a little bit different. So we're going to do the cosecant function. Looks like this. Again, no amplitude. As I said, sine and cosine are the only two that have an amplitude. Your period is back again, 2 pi over b. The only ones that are pi over b are tangent and cotangent. Your phase shift and vertical shift are c and d, but again, we're looking at the parent graph, so we don't need that for right now. So there's no amplitude. The period would be 2 pi, because it's 2 pi over 1, and your phase shift and vertical shift are going to be 0. Okay, so here we go. Since my period is 2 pi, I'm going to go out to 2 pi, and then I'm going to go out 4 more to 4 pi, just like I did with the others, except for tangent. We're going to have pi over 2, 3 pi over 2, 5 pi over 2, 6 pi over 2, and 7 pi over 2. Now let's look at that same. Remember, if I'm on the unit circle, if I look at my quadrantals, they look like that. So remember, cosecant is the reciprocal of sine. So if I plug in a 0, the sine is 0, which means the reciprocal is 1 over 0, or undefined. We are going to have an asymptote on 0. Let's look at pi. If I go to pi, again, the sign is 0, so the reciprocal would be undefined. And in fact, every 2 spaces for cosecant, you will have an asymptote. For tangent, it's every 4, but for this one, it's every 2. All right, so now let's see what happens at pi halves. Well, for pi halves, the sine is 1, so that means the cosecant is also 1. For 3 pi halves down here, the sine is negative 1, so the cosecant would be negative 1. What this looks like is you have little branches that look like this. They hug the asymptotes. So that's one period right there, and then of course you just repeat. Oops, that's a bad one. That should hug the asymptote for your second period. Now you're going to see that your secant function looks very similar. Here's how I tell them apart. Because your cosecant is the reciprocal of sine, and we know the sine is 0, your first asymptote is always on the y-axis. That's not going to be true when we go ahead and when we do the secant function next. But that's helpful for me to remember. Okay. Speaking of the secant function, here we go. So I'm not going to repeat that again. No amplitude. Period is 2 pi over 1, or 2 pi, and there's a 0 phase and vertical shift. Okay, I'm going to draw that little. Again, if it helps you to draw this, you can go ahead. So these are just your quadrantals. Okay, so since the period's 2 pi, we're going to go out 4 spaces, 2 pi, another 4 spaces, and we'll have 4 pi, and mark all of our quarter marks. So you should be experts at this by now. You could do it in your sleep, so I'm not going to talk all about it because you can pause the video while you catch up if you need to. Okay, so if we look at 0 here, the cosine of 0 is 1, which means the reciprocal, or the secant, of 0 is also 1. So we have a point there. But as soon as I go to cosecant, the cosine is 0, which means the reciprocal is undefined. So there's where I have an asymptote. Pi, the cosine is -1, which means my reciprocal is still -1. 3 pi halves, the cosine is 0. Flip it, you're going to get undefined. So just like with your cosecant function, every 2 spaces, there's going to be an asymptote. If I go 2 pi, well, that's the same thing as 0, so I'd have a dot up here. And then, of course, I'd have a dot down here, and I have a dot here. So, oh, I lost it. So basically what happens, my thing's not sticking like it should. So basically what happens is I have a half a branch here. I have a full branch, a full branch, a full branch, and another half a branch. Now, when I say you can graph, I want you to graph 2 periods, you can literally graph any 2 periods. So for example, if you wanted to get rid of this and then just put another asymptote here and finish off that, so you have 4 full branches, that's fine. But what you don't want to do is leave that there and do that, because as soon as you do that, you're giving me more than 2 periods, and that tells me you do not know what 2 periods is. Okay, I want exactly 2 periods. Okay, let's finally do our cotangent, and then we can just start doing a couple of shifts. So again, cotangent is the reciprocal of tangent. The pi over b is going to be important when we find our period. So there's no amplitude. The period is pi over 1, 0 for the phase shift and the vertical shift. Now, remember tangent, we centered a period around the y-axis. We don't have to do that for cotangent. So if we just go out 1, 2, 3, 4, that's pi. 1, 2, 3, 4, that's 2 pi. Half of pi is pi halves. Half of pi halves is pi fourths. I'm just labeling all of my marks. So 1 pi fourths, 2 pi fourths. This is going to be 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, and 7 pi fourths. Okay, so again, one more time here, but I think it helps. -1, 0, and 0, -1. So remember, cotangent is going to be x over y. So if I go to 0 and I do x over y, that's undefined. So we're actually going to have an asymptote there. Pi fourths, remember pi fourths is right here. What is the cotangent of pi fourths? It's 1. Pi halves, the cotangent would be x over y, so that would be 0. 3 pi fourths would be out here. It would be a -1. At pi, if I take x over y, I have another asymptote. So one branch or one period of the cotangent graph looks like this. So you'll remember the tangent graph was an increasing function. Cotangent is a decreasing function. And then, of course, we can just repeat here. So we would have a 1, a 0, and a -1, and we'd have another asymptote right here. And there's your cotangent. All right. A couple of things. And this is actually review, but they bring it up. I'm just switching my pages here. But they bring it up again, so I thought, well, we'll do a quick review here. So this means that it's an even function if f of -x is equal to f of x. X's can be thetas. And remember, even means it's symmetric with respect to the y-axis. So if you remember our cosine function, which I'm going to go back to my picture, our cosine function is the only even one. If I were to continue this, do you see it would be symmetric with respect to the, symmetric with respect to the y-axis. I think I said x, it should be y. That's true because it's an even function. So there you go. Symmetric with respect to the y-axis. Name the even functions. Remember, those are only cosine theta and secant theta. Odd functions, f of negative x equals negative f of x, symmetric with respect to the origin. So for example, I'm going to grab one of my graphs here. If I grabbed, oh, how about the tangent one? Can I find tangent? Can't find tangent. Here's tangent. If I graph my tangent one, this is an odd function, and notice it's symmetric with respect to the origin. Well, the pages are all messed up. Name the odd functions. Well, they are tangent theta, cotangent theta, cosecant theta, and sine theta. Okay, so again, we've already done this, but let's just quickly do it again. Since this is odd, it means the sine of negative theta is the negative sine of theta, which is negative. And what is the sine of 5 pi 6? Well, if you're looking at your unit circle, or if you know your unit circle, you'll know that that is actually 1/2. Secant of negative 150 degrees. Well, that would be the secant, the same as the secant of 150 degrees. Why? Because it's f of negative x is the same thing as f of x, which is 1 over the cosine of 150 degrees, which is 1 over the cosine of 150 degrees is root 3 over 2, which means I'm going to flip it to give me 2 over root 3. And then if I get the radical out of the basement, my final answer will be, oh, and cosine's negative. That's my bad. Cosine's negative in the second quadrant, so this should be negative. So it's going to be negative 2 root 3 over 3. I caught myself. All right. I think I'm going to end this and we'll start another one.